We have talked about scientific notation before, and we've used it in some of our word problems and in other areas, but we've never talked about how do you add and subtract with scientific notation. So we're going to do a little bit of review. We're going to talk about the three components that makes a number into scientific notation. One, you can only have one digit maybe to the left of the decimal. This means that the number has got to be greater than or equal to 1 and less than 10. Two, you know that it must have a multiplication sign in it because you are going to be multiplying with 3. It must have a power of 10. So you're going to have a number that is going to be between 1 and 10 and less than 10 multiplied to a number of base 10. So an example of this would be 2.35 times 10 to the third power. Just a little bit of reminding before we get any further. Now, we're going to look at some rules about adding and subtracting scientific notation. You can only add and subtract numbers as long as they have the same exponent in the base 10. If the exponents are not the same, you must move the decimal in the base to change the exponents in the base 10 number. So they are the same. Third, you're going to make sure that the sum or that the answer that you get is in scientific notation. It is not, then you are going to have to make it become into scientific notation. Four, just a little simple chart. If you were moving the decimal to the left, that means that the exponent of 10 is getting bigger, meaning you're going to add to the exponent. If you're moving the decimal to the right, your exponent is getting smaller, meaning you're going to subtract from the exponent that's already there the number of times you move the decimal to the right. All right, let's do some problems here with scientific notation, those that have the same base. Here, if you're looking at, I'm adding two scientific notation numbers, and they both have the base of 10 to the fourth power. So I know that I'm going to be multiplying 10 to the fourth power. Now I'm adding these two, so all I have to do is just line it up to the decimal, line the decimal up like you would normally. And I know that anything to the right of the decimal is going to be any number I can put it in, 0 in to save the place value. 287.7. So this answer is going to be 7.782 times 10 to the fourth. And yes, it is written in scientific notation, so therefore that is going to be your complete answer. Here I've got 9.89 times 10 to the second power plus 6.25 times 10 to the second power. I'm still working with like bases of 10, so I'm going to be multiplying this by 10 to the second power, and I'm going to add 9.89 and 6.25 by lining up the decimals and adding up my coefficient number, which is going to be 14, 11, 1, that's going to be 17. Notice when I have my answer, it's 17.14 times 10 to the second power. This is not in scientific notation, so in order to get it in scientific notation, I need to move the decimal one place to the left. When I move it one place to the left, I get 1.714 times 10, and do not forget when we're moving it to the left, we're adding the number of times we move the decimal to the exponent. I only moved it one time, so 1 plus 2 is going to be 10 to the third power. And that is my answer written in scientific notation. Same thing with my minus signs here. I've got to make sure that it has the same base of 10. And 10 to the fifth power is going to both there, so I'm going to put times 10 to the fifth power. And because I'm subtracting, I'm going to subtract 1.2 by lining up the decimals from 7.05. Now don't forget, if it's anything to the right of a digit and it's in decimal to the right of the decimal point, I can fill it in with a 0 to hold the place value. So 5 minus 0 is 5. I know I have to borrow from the 7 to get 6. 6, I'm going to borrow, make that 10. 10 minus 2 is 8. 6 minus 1 is going to be 5. So my answer is going to be 5.85. And luckily, that is already going to be in scientific notation, so I can just multiply it times my base 10 to the fifth power. Here, I've got another subtraction problem. I've got base 10 to the third power in both of my scientific notations. So I'm going to say times 10 to the third power. Now I've got 8.2, and I'm going to subtract from it 7.52. Remember to bring down and put in a 0, so to hold the place value. I know that I've got to come all the way over here to the ones position and borrow from the ones, borrow from the tenths, and borrow, and this will make that into 10. 10 minus 2 is 8. 11 minus 5 is going to be 6. And 7 minus 7 is 0. Notice this number, 0.68, is not written in scientific notation. In order to get it in scientific notation, I have to move the decimal one place to the right. And when I'm moving my decimals to the right, I'm going to be subtracting from the exponent base that I have already. So this will be 6.8 times one place to the right made me subtract 1 from the 3. So this is going to be 10 to the second power. Okay. Now, what do we do when we have bases that are different? The exponents are different. Well, first of all, I've put my little cheat sheet cards up here, and I've got, when we move the decimal to the left, we're going to be adding to the exponent, which is going to make it bigger. When we're moving the decimal to the right, we're going to be subtracting from the exponent, which will make it smaller. So let's look at this question here, this problem. 7.52 times 10 to the 5th plus 2.872 times 10 to the 6th. What I could do if I wanted to is just move this to the 6th power, since I already have the 6th power here. So let's make our base 10 to the 6th power. That one can stay the same, but this one I have to move. And in order to add to the 5 one space, I have to move my decimal one space to the left. So now I'm going to have 0.752 plus 2.872. When I add these together, I've got 4. This is going to be 12. 1 is going to be 16. And 3, carry my 1, is 3. So that's going to be 3.624 times 10 to the 6th. And that does work out to 10 to the 6th, and it does work out into scientific notation, so I don't need to move the decimal. Again, I have 10 to the second, 10 to the negative 1. I like working with my exponents as being positive, so I know that from negative 1 to 2, it has to be moved 3 places. So I'm going to make this 10 to the second power. I'm sorry, I'm talking about 3 places, and I'm putting 3 down. So I'm going to make it 10 to the second power, okay? And this number I'm going to move in order to add to it. What do I have to add to negative 1 to get to 2? I have to add 3 places. So I'm going to move the decimal place 1 place, okay? So that's 1 place, 2 places, 3 places to the left. All right? So now I can add it to this number, 4.072. So it's 0.0031. I can put a 0 there. Add these two together, and that's going to be that's 1, that's going to be 570. So that's going to be, my answer is going to be 4.0751 times 10 to the second power. This as well is going to end up in scientific notation, so I do not have to worry about rounding or moving my decimal. Here I have a subtraction problem. I have 10 to the negative 5 and 10 to the negative 7. Of course, negative 7 is further away from 0, so I'm going to move this up to a negative 5. So I'm going to change this to 10 times to the negative 5th power, okay? So I had to add 2 to get that negative 5. So I'm going to add 2 to that, which means I've got to move this decimal 1 and another one 2 places with a 0. So it's 0.0572 times 10 to the 5th. I apologize about that ringing phone. All right, so I'm going to subtract 0.0572, and of course I can add a 0 to the end of that from my 2.9740. So I need to borrow all the way starting here to the 6th. This is going to leave me with 13 and 10. 2 from 10 is going to be 8. 13 minus 7 is going to give me 6. 6 minus 5 is going to give me 1. 9 minus 0 is going to give me 9. And 2 minus 0 is going to give me 2. So my answer is going to be 2.9168 times 10 to the negative 5th power. This is also going to be in scientific notation, so that will be the correct answer. Here, I've got 10 to the second, 10 to the first. Now, I put that over there, but you know if 10 is by itself, it's actually saying 10 to the first power. The only thing I have to do is to get from 1 to 2 is move this decimal over 1 to the left, and then I can add it to that 1. So I've moved it one place. So it's now going to be 0.102 times 10 to the second power. Hold on just a minute. Sorry about that. All right, so now I'm going to take this 1.102 and I'm going to subtract it from, line up my decimals, 102. And I have to add a 0. Let's go ahead and just write this down here, 4.86. And then 0.102. And I can add a 0 here. Okay? So I'm going to go ahead and subtract this. And when I do, I know I have to borrow from here. Leaves me with a 10. 10 minus 2 is 8. 5 minus 0 is 5. 8 minus 1 is 7. And 4 minus 0 is 4. So my answer is going to be 4.758 times 10 to the second power. And again, always check to make sure it is in scientific notation before you go ahead and circle your answer. It always has to be a number between 1. It can be greater than or equal to 1 and less than 10.